Okay, so let me go through the website a little bit now that you've seen it and explain some things. So when we look at the topics, then we have 3 different topics and they're organized differently than the textbook. Whether you have the 12th or the 13th edition, they both work. All that's different is some page numbers. Then the textbook explains things by topic the way you understand them at the end of the term. Everything about ratios, everything about percents, but that's the wrong way to learn it. We need to go through the tools you use to do certain kinds of problems, whether they're a ratio or a percent or a measurement or a geometry, and study those tools one at a time. The context doesn't really matter. And then at the end, you'll look back at things and say, oh, okay, now I can sort of know all about percents, but I don't want to jump around and revisit the tools time and time again. That's confusing. I want to focus on the tools and change the contexts in the kind of circular pattern. So that's how we do the topics. On your lecture notes page, now we actually have things for this class from Monday. So there's the Zoom recordings might not work for you if you don't have a Zoom account. And LCC, I don't think forces anyone to make Zoom accounts yet, so that's fine. If you have one, that might be a useful link for you, otherwise ignore it. You can go to the playlist and see all of our recordings there. And each day after class, I'll go and I'll say, here is the PDF file of our board work, everything I wrote on the board. And then links for that Zoom and that YouTube video version of what we did that day. I have no idea, since I do have a Zoom account, if when you click on this, it does anything if you don't have a Zoom account. So if the YouTube alone is not what you want, then check into getting a free Zoom account. The advantage of the Zoom thing is that it tries to automatically make a transcript. So you can see on the side of the board everything that's being said. It's automatic, so it's not necessarily accurate, but for some people it's a lot better than nothing. There is another thing called Kaltura. By federal law, any video that's made at LCC has to have an accurate transcription for accessibility reasons. So LCC has a contract with a company called Kaltura. At the end of each week, I'll send my videos to them, and they will actually have somebody double check the transcription and make sure it's accurate. But for most people, then that's just sort of an extra thing. Okay, any questions about all your lecture notes that are available to you? Yes?
What's the YouTube account?
What is the YouTube account?
What's the YouTube channel? Where do we go to?
You click on where it says playlist right there, or on any of the YouTube links for each day's lecture.
Okay.
Okay, the library is for where you want to share things with each other. No one has given me anything yet, which isn't surprising, saying, please scan this so all of my classmates can see it. But if you have something great to show off or share, then that's where this will go. So if we go back to the front page, this top row is sort of the things I'm providing to you. The second row, yes?
I wasn't here last class. Do you have a syllabus?
Do I have a syllabus? I do, but I'll actually get to it. I don't have a printed version of it, but I have homework handouts that I will mention in a moment. If you want me to print the syllabus, I can, but it's on the website. Are you Daniel?
I'm Sean.
Sean, okay.
I need those too.
You need those too, and then I will hand them out.
Thank you.
Okay, the second row are the things that you're responsible for getting to me. So the first and most complicated is the homework. And I think I'll start talking about homework by asking a joke. What do you call a midget fortune teller recently escaped from prison?
Can you repeat that?
Yes, what do you call a midget fortune teller recently escaped from prison?
Scared.
That makes no sense.
A midget fortune
Yeah.
teller. You just-
The watermelon?
A small, medium, at large. Anyway,
What? That makes no sense either.
So,
I put some like Harry Potter thing out there since you put that in the email.
okay, so I'm telling the joke just to say I wish that math was like jokes and news and things. We could talk about politics, we could share jokes, and you might remember that without any effort forever. But math isn't like that. I would really like if it was like the Matrix and I could just come and plug something into your back. Ta-da, you know, Math 20, we're done. But that's not how it works.
That's not how the Matrix works.
Yeah, well, anyway.
How Star Wars works.
So, to learn math, you have to do work. It's like riding a bike or pottery or martial arts or all those kinds of things. I'm going to jump to the bottom of the homework page, which I delayed till today because, again, Monday is not the day for important things.
This is really fun.
So, it is completely normal to have 3 different levels of math understanding. At the first level, I dance around in the front of the room and you nod your head and everything is happy. You say, I understand it. And at that moment, you do. The second level, you can open a textbook and try and do some problems open book. And you can get those done. And these are 2 different things. It is completely normal to understand lecture, get home, open your book, and stare at it like someone did something to your brain. And what just happened? So if that's you, don't worry. That's just how people's brains work. The third level is you can do closed book work. You can take a test and not rely on the open book problems to mimic to get it done. And that's, again, a completely different thing in your brain than the second or first level. So the job of homework, the reason you have to do homework is that you need to move up these levels. If you were taking Math 25, level 2 would be the end. Everything in Math 25 is open book. But in Math 20, you actually need to get here. There's some things that you just have to do closed book. Yes?
Question. I sent you an email with the code, and it took me a minute to figure it out because I clicked the link on the email thing that.
I'll get to the code in a moment.
Well, no, I don't know if I did everything right. Because I did the rounding part, but is that the only thing we're
Yeah,
supposed
the
to do?
rounding was all you're supposed to do.
So not the other stuff then?
No, we haven't talked about it yet.
Okay.
So. Okay, so you're doing homework to try and move up these levels. And that's the goal of the homework, right? No one cares what your homework score is in week 1 of a math class. The only reason you're doing homework is to try and go up to the 3rd level of understanding for these topics. Okay, the first thing about how to do homework is that you need to budget your time. So treat some homework as what I call prompt homework problems. Ideally, you will do some homework today. Not a lot necessarily, because we have jobs and kids and all of that kind of stuff. But set aside 10, 15 minutes, and you're going to test yourself and see what level of understanding you are for the rounding and the fractions and the other stuff we're doing today. And then you'll know, can you party this weekend or not, because what's happening, right? So this is to budget your time. This is to get a good sense of where things are in your brain. Then, not necessarily today, you're going to do enough homework problems, whatever you need, so that you can do a problem of that kind, and ta-da, you've mastered that, it'll work. Okay, when is homework due? The homework you turn in, you can try to turn in more than once. We'll talk about that in a moment when we're looking at that code page. So turn it in as many times as you want, and it will be officially due a week from the last day that we talk about that topic. So we're not done with rounding yet. There'll be people who have questions about the rounding homework in a moment when I'm done with announcements. But maybe Friday we will. If I say, okay, welcome to class on Friday, who has questions about rounding, and no one does, then we're done with rounding, and a week from Friday, the rounding homework will be due. Does that make sense? I don't know how fast we'll go through all the material, because from term to term, people have questions about different things. I know mostly how fast we go, because I've done this a lot before. But I have never had this particular group of students, and so you will determine the pace a little bit. Yes?
Friday's mandatory.
Our Friday is mandatory. Homework is not graded. It's just really hard to pass without being here. I'll talk about that a little more. You don't have to come in to do homework.
So So what's Friday?
Friday's class.
There's a class on Friday.
Yes, but why? Like, is this a 3-day class?
Yeah. It's a 3-day class.
Okay.
Okay. Another thing about homework is it's never optimal to do homework by yourself. You can. Some people are just kind of lone rangers, either by personality or by scheduling restrictions, and they have to. But you will learn more if you talk to other people about the homework. Just like it's easier to go running in the mornings if you have a running partner, right? We're going to go running at 7 in the morning. I don't want to go running at 7, but if I'm not there, I'm going to disappoint him. And he gets out of bed for the same reason, that kind of thing. So if you can't actually get together with someone and make a study group, then exchange phone numbers with someone and say, I'm going to do homework whenever, Thursdays at 8 p.m. And if I have a question, I'm going to call you and you'll do the same. And if you have a question, you'll call me. And even that is better than nothing. So similarly with the codes, you can turn in a code with people you've worked with. If Unique has turned in a code and she's worked with these 3 people in a study group after class, then she can say, by the way, this is for these people too. That's fine. Okay, let's talk about the kinds of homework. The first thing you want to do is go to the topic and try and do all the problems we did in class again yourself. Those will be the most sort of fresh and connections in your brain because we talked about them that day. So you probably won't be able to do them all. Again, you had level 1 understanding of following me when I'm up here, and now you're trying to get to level 2. So when you get stuck, then look at what we did in class. Sometimes you can hit shift and see the answers pop up and so on like that. But correct those first. When you've done that, then the next thing to do is the textbook problems. So you have a handout, a yellow handout, and that's listing what to do in the back of your textbook. And again, this is sort of the average amount of homework. If your math background is strong, you might not need to do all these. You'll get bored and be ready to move on. If your math background is weak, you might want to do more odd numbered than these. But do enough practice so that the next time you're about to do a math problem of that category, you think you're going to get it right. Then, if you need more practice, we have random problems. So every time I load this page, I get a new set of problems about rounding. Only 3, but hey, better than nothing. So that will give you some more practice. Skip that if you don't need it, but it's there as a resource. Because I do, believe it or not, have people say, your class needs more homework. I ran out of things to practice on. So there you go. Then finally at the end, the icing on the cake. You've done a lot of other practice and you think that you're going to be accurate and you're ready to turn something in and be graded. Then you'll go to the turn-in homework, one moment, and there'll be 10 problems for the topic. Again, we've only done the rounding topic as far as things we finished talking about in lecture Monday. So you'll say, here's my 10 problems, do them on paper first. It's just, for most people, really annoying to try and stare at a screen and do them from the screen. So your green handout is just a printout of this page. It's the 10 problems for each of our subtopics. So you can open this and you can open your textbook. Maybe you have a screen, a phone, or a tablet, or a computer to look at our website notes if that helps you. But whatever, try and do these 10 problems. This is the last thing to sort of prove to me that you can do it. By the way, I had not quite a dozen, but lots of people turn in codes since Monday. No one got the 8 out of 10 right to be done. So if you turned in codes and didn't pass yet, that's fine. No one did. You're supposed to be here. Everything is good. So turn this in as often as you want. When you click on the place to turn them in, then there'll be multiple choice things you'll click. Don't look at this as you do the problem. This is just to turn them in. And then at the end, it says process my answers. So that you'll get a code, click the code, go to an email, paste, send me the email. If you want to get graded as quickly as possible, start a new email to me. And in the subject line, say rounding homework, and then just paste the number, and that will be good. If you reply to my after the class email, then the way Gmail hooks everything together into one long super email, then that's harder for me to parse and grade and things like that. So after class, if I'm rushing to get kids from school and take them to gym and all these other things, I might have time to reply to a few people, but I might not parse the giant email of everyone who was lazy and replied to my email. Hopefully by dinner, but we'll see. So start a new email if you want to sort of make it easy for me. That also makes it so that Gmail will start a chain that's just us talking. So it
But
makes
if
it
you
easy.
do it like that.
If it's okay, either way works.
Yeah.
But I might, there's enough students that I might forget that Unique has turned in this before and say, you know, great start, 7 out of 10, when it's really her third try and I forget. So I can be a little more personal if we have our own conversation thread going than the giant one with everyone. So, but up to you. I will get it either way. A few of you.
He doesn't understand.
So what homework will we assign Monday?
What homework on Monday? The rounding topics. So rounding here, rounding there. This one comes first. And rounding isn't due. It won't be due until at least a week from next Friday, right? Because,
Now my question, I did that page.
yes.
I didn't do, there's 2 pages you have to do?
No, just this one rounding page.
Just that one round?
Yep, no one's gotten 8 out of 10 right to be done with it because you need 80% to pass. But so keep trying.
Okay, well, I don't even know if you got the right one for me because am I supposed to make an account on this? 'Cause you
Now,
said
everyone that sent me an email I've replied to, unless you did it just a few minutes before class. So if you didn't get a reply from me, something's fishy.
Okay, I'll
I
check
understand.
that out.
So, by the way, a few people used my personal email, not my vancelyd@lanecc.edu email, and that's also slower. I might not check my own personal email as often as I try and get the homework rating promptly dealt with. So use the school email for me. I'm not sure if on one of these pages I put my other one by accident, let me know. I'm not sure where everyone got my personal email that did that. So, okay, questions about this? Okay. So hopefully when you do homework this way, starting by reviewing things that looked like what we do in class, moving to things that have lots of sample problems to copy and mimic, and also another way of explaining it, right? This is again more like a lecture. And then finally, the icing on the cake problems you turn in that are the least like a lecture. It's trying to guide you from that first level of understanding where you follow a lecture to that second level of understanding where there's no lecture, it's just open book work. So that's the intent of this homework process. Okay, achievements. Some of you sent me code names. Thank you. Hopefully I replied. If not, then I messed up. But there's the code names people have sent me so far, except for Abe, which was just my placeholder. So all of the things you'll be graded on are here. And when somebody does get an 8 out of 10, then there will be a check mark on the rounding one here when that finally happens. And lastly, eventually there'll be practice tests, but I don't have them ready yet. The last row are generally helpful things. So it starts with the study skills. Look over that. There's good things. With 2 holidays making us miss classes on Mondays, I don't have time to go through this during class. I might a little bit, but most of it is just read on your own time. It is good stuff. There's the resources at LCC. Again, read that outside of class. It's silly for me to just read it out loud from the screen at you. And lastly, our syllabus, which has all sorts of important things, especially if it's snowing. So, okay, questions about any of that? Also, if you weren't here last time, you can get the 12th edition on Amazon. What is it today? $11.98. So if you paid too much for one of these books, then try and sell it back, right? Return it, get the cheaper version. And I don't know if I clicked the link last time. If you like mimicking things, then this Student Solutions Manual, it's not 44. That gives you step-by-step answers for every odd-numbered problem. So you will never run out of example problems if you have this. Very few students get this, but sometimes students that have study groups will order one copy and share it. I have no idea if the LCC library has one of those on its shelves. That would be a good thing to know. Yes,
Does this work for the 13th edition too?
I'm sure there is an equivalent one. I don't know what the cost is.
Okay.
And at the very least, you can take your yellow page with the textbook homework and say, once it starts saying page this or that, just switch to the other page.
Okay.
So a little awkward, but if it saves you money, make it worth it.
And this like helps like break down the problems and stuff.
It gives you step-by-step for every odd-numbered one. So the books both have a lot of example problems in them. So that might be enough. But if you really like example problems, then here they are. There's, for 44, it might be cheaper to get an online code. I don't know if the online codes that the publisher sells, what they give you access to anymore, but they might give you that without having to have a physical copy. I don't know if that would be helpful. So, okay. So that was announcement time. Didn't take as long today. Any questions at all about how the class is going to go? Okay, so let's start with review. We did rounding Monday and then barely started fractions. So let's look at what we did. We talked about place value and how decimals sometimes have accuracy because we really measured things carefully. We talked about how division can give us lots of decimal points that are phony. No one actually measured things that carefully. It's just that when you do division, you get decimal places. So how many should you keep? When should you do rounding? We had examples that said there might be certain tools, like a pharmacist scale or a carpenter's saw, that told you, yeah, this is about how accurate we can actually be. If it's just some random word problem in a math book, the general rule is to use the same number of decimal places as we originally had in the problem, or perhaps one more. Because splitting things up into piles does sometimes make it more minute, give us a little more accuracy. So that's the rule for when to round. We talked about, oops, by the way, did anyone click on the OER links at the end of each subtopic? No, okay. If anyone ever does, I would love to have feedback. I'm not on the committee that actually is trying to figure out what to do once we're done with Bittinger over the summer, but there we go. And then videos, okay. Then it was your turn to round. We talked about how to do rounding. We did lots of example problems. We found where someone made a mistake in the tricky problem. There we go. And then we briefly mentioned estimating. Normally you don't want to round until the very end of a problem because you'll get it wrong. But sometimes it's okay to be wrong. You want to estimate, start the problem by rounding and get sort of a ballpark idea. Is this about 100 or about 1,000,000? And then when you do the work, if your calculator has something wildly off, you'll be clued in that you hit some calculator button wrong. So that was all the rounding. Questions about rounding, homework problems that you want us to do on the board? Yeah.
Those homework assignments. Those homework assignments.
What about them? Oh, you want them? Yes. I think I have one more of each. Can you pass this back?
Actually, I wasn't here last class, so do you have any more copies of them?
Not with me, but I can copy some after class. So follow me around if you don't have to go anywhere.
So on the last question in the homework, the meta and deletion thing with the meters, and he has numbers that go into the thousands. Their numbers are so close, I actually didn't know what to say
Say?
for the last one.
Okay,
I
let's
didn't
look
know
it up and
whether
see.
to share them.
Let's open a new thing. So this is the turn-in homework or the textbook homework? Which one? The turn-in homework.
So we were assigned.
Yeah, I had a little
Ah,
trouble with the
these
last
three.
three too.
Okay, well, let's do just one pair for now. I hesitate to just give away turn in homework things. But we want to first do some estimating and then see what it really was and how much the estimating was off. Okay, so for number 8, how should we round this? What kind of estimating should we do?
I rounded it to 3 and then 1.
You rounded it to 3 and 1. Okay, so you made a
I did too.
picture that was 1, 3, 3, whoops, 1. There we go. Oh, come on. There. Okay, so add up all of those. And we get the sum is 8, and this is meters.
I did it different. I added the decimals together and then rounded it.
So you added things accurately and rounded the answer at the end? Okay.
Would that work?
No, that's not estimating. It might be a good thing to do, but it's not what this problem is asking you to do. To estimate, you have to round first. So you could round it to 2.7 and 1.2. Did anyone do that? You did? Okay, so let me draw that also, because it's also a valid thing to do. So what do we have?
We still have
4,
3 and 1.
5, 6, 7, 8.8. Am I doing that right in my head? 7.8, yeah. 8.8 seemed too big. Okay. So either of those is fine because it didn't tell you which way to estimate. Okay, then for 10, if we actually do it correctly, it was 2.74. Is my memory okay? What was the other number? 1.22. I trust my mental math. 7.92. Okay. Okay, what the difference is depends on which of the versions of problem 8 I did. So if you answered 8, then we're off by 8 minus 7.92 would be 0.08. Or if you answered it the other way, nope, not 8. It would be 7.8. So that would be 0.12. Okay, did I do all my math right? So we haven't actually finished number 10 yet. You'd have to do the same thing for the other garden bed and see which of these numbers were closer. Maybe I'll do that Friday. I don't want to spoil the whole thing today. Okay, other rounding homework questions from this or from other places.
Number 4.
Number 4, which was that? Round that to the nearest 10. Okay, well, I'm going to rewrite it big because that helps. which am I looking at? The 9 or the other 9? Yeah, I want 10, not tenths. So I'm trying to round to that. So I'm going to get rid of all that stuff. I look at the biggest thing I get rid of. Is that 5 or more? Yes. So that means I have to take the 9 and change it to a 10. When I do that, everything else turns to 0, and I don't actually have to write any of the decimals. And I can't just take the 9 and make it a 10. What do I do?
You take the 3 and make it a 4.
Yeah, take the 3, make it a 4, and we're done. Okay, other rounding questions?
I don't remember what number it was, but one of the rounding ones with big numbers.
One of the rounding ones,
This one right here, number 5.
5, okay. Now, a lot of people turn things in. I'm being generous. If no one has tried turning the codes in yet, then I would say, no, this is the icing on the cake. You have to do the other ones. But for now, I'll be too friendly. Okay, round to the nearest 10th. Which of these 7s am I rounding to? The 10th is the decimal place one. So I'm going to get rid of that. Does the 2 make me do anything? No, that's tiny. So we're done.
Do you have that as an answer in there?
Do I have 9, 8? I don't know. 9, 8, 807. This was 5. Oh, no, I messed up. Okay, so I'll make a note to myself, fix this.
I kept doing it, and I was like, there's no way. I even had my husband check.
Oh, well, yell at me when I make this. Thank you. Oh, a lot of these I got done while traveling. My winter vacation involved going all the way down to Southern California with my wife and 8 and 11-year-old and visiting all sorts of friends and family. No one for more than 2 nights at a time. So I'm trying to get this done.
What part of the couch?
We have family in Escalon. If you've never heard of Escalon, it's near Stockton. So it's a great halfway place between here and San Diego. We have family in San Diego. Then we went up to Santa Paula. And then we went over to Joshua Tree and then Idlewild. Oh, and there's Orange County. And then we came back up. So too much driving. I need a vacation from my vacation there. Anyway, yeah, so I probably have typos places. So I'm sorry. Okay, fractions. So we started fractions just a little bit, and we started by talking about division. And that division, you could think about dealing out cards, and for some reason, elementary school teachers like this way of thinking about division. And then we talked about making piles of the fixed size, which for some reason, elementary school teachers avoid, even though it helps you more in certain cases. Does all of that ring a bell? Is it okay if I just keep going instead of repeating that? So, then this part I do want to repeat because it's worth repeating. When we play with fractions, we need to find factors of things. So we can reduce the fractions, so we can find common denominators. And the factors of a number are what you multiply to get there. So there was this nice picture. So what are the factors of 12? 1 and 12 make 12, 2 and 6 make 12, 3 and 4 make 12. So those are all factors of 12. How do you find factors when you need to? There's these rules, some of which you may have known before Monday, and some of which might have been new to you on Monday. Let's take up, did anyone get exposed to one they never had seen before on Monday? Raise your hand if that was you. Only one honest person. Okay. So a number is divisible by 2 if it ends in 0, 2, 4, 6, or 8. A number is divisible by 5 if it ends in 0 or 5. A number is divisible by 10 if it ends in 0. Everyone needs to be taught those. The ones that people might not have been taught, if not, it wasn't your fault, it was your teacher's fault, was for 3 and 9, you add up the digits, and if 3 or 9 goes into that sum, it goes into the original number 2. 6, if 2 and 3 both work, 6 works. And 4, just look at the last 2 digits, depends in one's place. So let's just make up a number. Somebody just start saying some digits. 23, okay, 23,000. 469. Okay. So we're going to check if this is divisible by 2, 3, 4, 5, 6, 9, and I suppose we might as well write 10. Okay. So is 2 a factor of this number?
No.
No, it's not even, right? It ends in a 9. Is 3 a factor of this number? We have to add things up. 2 plus 3 plus 4 plus 6 plus 9. 4 and 6 is 10, plus 9 is 19, 21, 24. Does 3 go into 24? Yes. Three is a factor of 24, so it's a factor of the other big number 2. For 4, I just look at these 2 here. Does 4 go into 69? No. (69) is odd, and 4 never goes into an odd number. Okay, 5. Is 5 a factor? No, one's digit is 9, same as before. Whoops, that wasn't a paste. There we go. For 6, do 2 and 3 both work? No, 2 didn't work. No, 2. Does 9 work? Well, we look at that sum. Does 9 go into 24?
Yes.
No. 9 would be 27. And does 10 work? No, same thing as before. It ends in 9. So if this was part of a fraction, I might want to start by dividing it by 3 to simplify it, because 3 seemed to be a good one. Questions about the divisibility rules? So it's on one page. Okay, if your mental math is rusty, and I will make lots of arithmetic mistakes with my mental math this term. It is not why I am a math teacher that my mental arithmetic is somehow better than everyone's. It used to be better than it was now, but my wife is the primary breadwinner at my home, so I was the one that stayed up all night with the infants, and that destroys your mental arithmetic. So anyway, if you need to practice, then multiplication tables are boring. So it is more fun to play the factor game. If you have kids that are learning the multiplication tables, you can teach them the factor game. How this works, we're going to split the room in half. So everyone here, you are one team. Does this team have a name?
Team one.
Team one, okay. And this side of the room is the other team. Does that team have a name? Team three, okay. Actually, I'm gonna just make it X's and O's since you didn't think of creative names anyway. So X's on this side, O's on this side. You're going to, on your turn, claim any number that's not covered yet. And then the other team gets to reply by getting all the factors of that number. And then it'll switch. And the second team picks any number at all, but the first team replies by getting all the factors of that. And at the end, it's not how many squares, but it's the value of the numbers. So getting 30 will get you more points than getting 1. Because you're going to add up all the numbers that your team covered. Okay, so this was X's, right? Okay, X's, pick any number at all.
18.
18, does everyone agree that's a okay one?
Yep.
Okay, so X's is getting 18. So O's, make it blue.
30.
Factors of 18. It's not your turn yet, you're just replying. So 1 for 1 and 18, and then 2 and 9 makes 18. So at the moment, it's 18 points to 12 points. X's are ahead by 6. Make sense? Okay, O's, your turn to start and pick any number you want. Oh, 3, yes, I'm sorry, 3 is a factor. And what else? 6, okay, so actually the O's score is now 21. Yeah, so that wasn't a good turn for X. They got more points than you did. Okay, oh, your turn to start and they get to reply. 30?
13.
Those are okay. 13.
10.
You don't get to pick 4 then. Hey, your 2 numbers. Any consensus?
13.
13. Okay, so they pick 13. Any other factors of 13? Just 1, which is covered already. Okay, X, your turn to start. Any number
30.
at all.
5.
30.
I think.
4.
4, 5,
Hey!
13. You're not on this team.
5.
I hear 7 more than others. Okay, so X's get 7. Whoops, that's not X's column. So 7 has no other factors other than itself and 1. What's the name for those, by the way? Prime numbers. So, ta-da, you get 7 points. They can't do anything. Okay, oh, your turn.
Twenty.
4 and 20. Anyone else want to chime in on the O team? 20. Oh, okay. So O gets 20. X's do have some replies. What do you get?
10.
10.
2.
Whoops, that's
4.
one moment. I'm doing this wrong. That's an O.
5.
So, come back. Okay, 10. No, I'm
We can't use 2.
10, 4, and nope, 2 is claimed already. So a small gain. Right, X just got 19 points. Blue O's got 20, so they came out a tiny bit ahead. Okay, X, your turn to start with a brand new one.
Oh, 8.
15.
Wait, 11.
11.
11, okay, 11 is one of those primes, O doesn't.
Yeah, we'll get 11 points right there.
Okay, get 15. No problem at all.
8 for the O's? Okay. 8 isn't prime, but 2 and 4 are taken already, so they don't get to reply. Okay, X, you had a good idea a moment ago. 15. 15 isn't prime, but 3 and 5 is taken already, so they don't get a reply. O's turn?
19.
19. Other O's happy with that? So 19 is a prime.
30.
Okay, 30. Now it might be safe enough to get 30. What are the factors of 30? 1 and 30, 5 and 6, 15 and 2. So that's a bad play at the beginning of the game, but now that was a good one. Okay, and we're actually going to stop. I don't care who wins this game. But now you know how to play the factor game, and if you need to practice your multiplication, now you know a fun way. Okay. There's two things we want to do with factors that are more math classy than a game, unfortunately. One is finding all the factors. Sometimes you just want to find all the factors of a number, and there's a routine to do that. We're going to make a 2-column list. We're going to count down in the first column and list the factors that go with that in the second column. And when the columns get down to the same value, we stop. So let me show you. So I start by counting 1. 1 goes with 66, because 1 times 66 is the 66 we have. 2, is 2 a factor?
Yes.
Yes, 2 and 33. 3, is 3 a factor? What goes with 3? Not 11.
22.
22. Is 4 a factor? No. 5? No. 6. 6 and 11. 7? No. 8? No. 9? No. If you weren't sure about 9, 6 and 6 is 12, and 9 doesn't go into 12. 10? No. 11. So we got back to 11. We're done. So these are all the factors of 66. Let's do another one. So we'll start with 1, and 1 times 24. 2. Sure, 2 times 12. 3. 3 and 8. 4. 4 and 6. 5. No, then we're back up to 6 and we stop. We stop because if anything 6 or bigger was a factor, it would have to have a tiny thing to match with it, and you would have already seen it. So that's one game about factors. You're going to make a horseshoe, and that helps when you find all the factors. When would you want to do that?
In fractions,
In fractions? Yes. What kind of fraction?
dividing.
No, you don't need that for then.
Improper?
Adding. When you're trying to find the least common denominator, then you want to avoid duplicating things. So that's a good way to help with that. Okay, there's also finding prime factors, which is the factor tree. This one is more common. Elementary school teachers like this one more than horseshoe. So if I start with a number like 48, I can break it up into factors. In this case, somebody took 6 and 8. Then we break those up if they're not prime. 6 becomes 2 and 3, 8 becomes 2 and 4. If the 4 isn't prime, we'll keep breaking it up. And at the end, we can say we've done all prime factors. I want to do another one that doesn't start with 6 and 8. So how else could we break apart 48? other than 6 and 8. 24 and 2, okay. So 2 is prime, 24 we can keep going. 12 and 2, okay. 12 we keep going. 6 and 2,
And then 3 times 2.
3 times 2. Okay, now we're done. When you make a factor tree, the danger is that when you're taking a test and your brain turns to sludge, which sometimes happens on math tests, that when you're writing your answer, you will miss something. You'll write 48 equals 2 times 2 times 3, forgetting one of the 2's or something like that. So what we want is a thing that helps us not make a silly mistake. There's 2 different ways people do that. One is they circle all of the leaves of the tree. That helps them not neglect any when they're writing their answer. The other thing would be to bring things down. Once you get a prime number, you just keep bringing it down every time. And then you can read them off at the bottom. So pick whichever style you want. And I'm going to make this be something there. But do something so you don't make a silly mistake, because that would be sad. Okay, I'm not actually done. I should write my answer. So 48 equals 2 times 2 times 2 times 3. A couple comments. I'm using dots for multiply. If you use little time symbols, that's fine. I've just done enough algebra in my own personal history. I don't like writing x for times because x is like x. But if you like x for times, that's fine. Also, if you are fancy and want to do exponents, you could write this as 2 cubed times 3. That's fine too. I'm not going to do it now because we haven't officially talked about exponents yet. But if you like them, more power to you. Yes.
Got it too.
Oh, I did. My own silly mistake. Thank you. There we go.
2 squared.
Yeah, 2 to the 4th now times 3. Okay. Other question, now that we got it right. Here, why don't I stick to that? Back up there. Okay. Should we do more examples of factor trees, or are people okay? Okay, let's wait till we're actually using. Okay, onward to fractions. All the stuff about factors was building up to fractions, so let's do that. Okay, we have a fraction. Let's talk about making denominators the way we want. So here's a cake. 1/3 of it is shaded. Maybe this is a third of the cake I get to eat, or something like that. If we want, we can keep cutting the cake. So I'm going to change this 3-piece cake into a 6-piece cake with 1 cut. Where should I cut it? All the pieces need to be the same size. Across, right? Something like that. Okay, now I have 6 pieces. How many of my pieces are shaded? 2. So we had 1/3, and now it seems to be that we have 2 of them shaded out of 6. What about if we take the 3-piece cake and make 2 cuts? Again, pardon my artwork. So we started with 1/3. Now we have 1, 2, 3. And how big are those? They are 9ths, because there's 9 of them there. So unreducing, taking a fraction and multiplying the top and the bottom by the same thing, is just like cutting your cake more. Why am I multiplying top and bottom by 3? Because each of the original pieces I'm breaking into 3. Why was I multiplying the top and bottom by 2? Because each of the original pieces I'm breaking into 2. Okay. Be careful how you write this. If I want to write what's happening, then I could write 1/3 with some little floating times 2s. I'll actually use x's this time. That's fine. That's clear. Everyone knows what you mean. I could write 1/3. Whoops, let me keep consistent with my colors. And then write times the fraction 2/2. That's much less common, but there's nothing wrong with it. I would still get 2/6. Some people love canceling. And so even though this isn't canceling, they're going to write little cancel cross-out kind of marks and say that that's the same as 2/6. Kind of, I don't know, not precise, but that's fine. If you like that, that works.
But are they all correlating with one another though?
Yeah, but you're not being clear about times 2. You're not communicating what you really did. Right? So what you don't want to do is this one. If I have my 1/3 and I just put a single times 2 in the middle, then a whole number 2 is really the same as 2/1. So this is going to be 2/3, not 1/6. Does that make sense? So don't do that. Any of the other ways is fine. Okay. Reducing is the opposite. So I could say that I have a cake. I can make pink slices, that's fine. So I have 6. How would I reduce that fraction with my picture?
Divided by 2.
Yes, I'm going to do a divided by 2 top and bottom and get 1/3. What do I do in my picture?
Erase that are mine.
Yeah. Right, there we go. So if you had some sort of magic cake icing frosting stuff and you glue your pieces together, that's all that's happening when you're reducing fractions. And the same warnings apply that when you're doing this, you could write a divided by 2 top and bottom, but don't just write 1 divided by 2 in the middle. That would be wrong. Okay, definitions. When we reduce a fraction, we're dividing both the numerator and denominator by the same value. And it's fully reduced if we've done that as much as we can. The only factor they have left in common is 1. Okay. We're going to do this 2 ways just to encourage people that are a little fond of the number 2. If I started with 8/24 and I just liked doing divided by 2, I could do that. I could say we'll divide by 2 top and bottom. And we'll do it again. And we'll do it again. And finally, we get to 1/3. There's nothing wrong with that. No one is going to ever grade you in this class on your efficiency of reducing fractions. So if you just like to whittle away a little bit at a time and it doesn't slow you down too much on the tests, it will work great. You could also enjoy being clever and say that when I started with 8/24, I can see that 8 goes into both of those. And I can get to the same 1/3 answer with much less writing. And if that works for you, then that's great too. So either one doesn't matter to me. Okay, questions about factors or unreducing or reducing? There's the greatest common factor, which would be the biggest factor they both have in common. So what we just did before was we saw that the greatest common factor of 8 and 24 was 8. So that will clear it out to 1/3 in one step. It's nice to have that word greatest common factor. The phrase will sometimes be used. Okay, let's do a biggie. I think it's your turn to do something. So I will do this in a moment, but first work with yourself, work with a neighbor, and see what this monster turns into.
Yeah.
And I wonder, this can be reduced further.
True, yeah.
What can be divided by 5? This one, I don't know.
Yeah.
I'll use a straight up 5. Yeah.
How are people starting? What number are they dividing by first? 2, okay. So half of 300 is 150, half of 30 is 15, so 165. And this one would be 231. Did I get that right? Oh, how did I said that 330 is going to be 300 plus 30, and took half of each of those and then squished it back together. You could write out long division, that's fine. It just takes too long for me to write the long division all the time. Okay, we're not done yet.
Well, I know that you could probably divide 165 by 5, but 231 looks like a straight up prime number. You can't really do anything with it.
Remember our divisibility rules. If I add up the digits, 1 and 6 and 5, what do I get? 12. And if I add up 2 and 3 and 1, I get 6. So 3 is going to go into both of those. Okay, I could go 3 into 165. So 3 times 5 is 15. And 3 times 5 again. And I can do 3 into 231. 3 times 7 is 21. Okay, so far so good. 11, yeah, the 11 wasn't visible before. There's no easy rule for 11, but now that I have 55 and 77, I can go 5 sevens. Okay. Okay, if you got that far, congratulations. I won't make you do that on a test. At all. Okay. Okay, questions about how that works? Okay, we're almost out of time. So now it's true that we've finished not only the rounding thing, but a fair amount of the fraction format. We're about to start decimals and fractions. So you probably tonight aren't going to do the fraction format subsection of the turn-in problems. We haven't finished yet, we're not going to. But you might be able to start the homework on them in the appropriate ways.
What numbers you want to do?
On the green sheet, on the turn-in ones, so far only rounding is ready for.
Oh, so none of the fractions?
No, we won't have
Oh.
finished it. Remember the turn-in ones are the icing on the cake. They're all done and ready, which for fractions you probably have.
So the homework that you signed is just for our practice to get up to the ones that we turn in.
Yes,
If we are ready to do them, can we do it?
you can try. It does. Okay. What?
Yeah.
Don't pack up yet, I'm just distracted. We still have 5 minutes. Yes, on Friday is short. But we're not done. Let's start fractions and decimals a tiny bit, even though we probably want to review it on Friday. So, what? Once you get there, be careful. So turn it. Okay, as a reminder, the brown numbers at the top are where to go in the literature textbook to talk about this kind of thing. So if you're not sure which homeworks to practice, then that's your clue. Okay, we want to start moving between percents and decimals and fractions. We haven't done anything with percents yet. So for now, we'll just go back and forth between fractions and decimals. And the easy one is to go from the decimal to the fraction, because all you have to do is say its name. Remember that there were different ways to say this decimal. If I'm lecturing, I'll say 0.08 to give your ear a little heads up that a decimal is coming with 0. If we were just working side by side in office hours, I'd say 0.08. And if I was a stenographer in a court of law, it wouldn't be 8/10, it would be 8/100. Everyone see why? So it's 8/100. So I can just write 8/100. And ta-da, it's a fraction. Unfortunately, there's this annoying rule that a fraction answer isn't done until it's fully reduced. So I made it a fraction, but I'm not done yet. I have to say, let's reduce this thing. So those are the steps to turning a decimal into a fraction. Say its formal name, and then reduce it if you need to. Almost everything in math and physics is named after famous people, right? Kepler's laws and so on. But whoever makes this rule of you have to reduce fractions, they didn't want their name attached to it. I'm not sure who to blame. Okay, let's do the other one. 125, what is my denominator? Thousandths. So if I have $1.25, how many quarters do I have? 5. And if I have $10, how many quarters do I have? If I had $1.25, I have 5 quarters. If I have $10, how many quarters do I have? 40, right? Each of the $10 is 4. I'm not done reducing things. Oh, okay, there we go. The other direction, we have time, maybe.
4 minutes.
We won't make it. The other direction is to make a fraction a decimal, we treat it as a division problem. So if I have 1/5, I'm going to say that's 1 divided by 5, and that's 0.2. Will I actually write out the 1 divided by 5 in the middle? No, but I'm lecturing, so I'm writing too much. If we have 3/8, I'll do 3 divided by 8, whatever that's going to be. So, whoops, wrong way. Okay, let's review a long division when things don't fit. I can't fit 8 into 3. What do? Yeah, I add a 0, and when the decimal point goes here, it also has to go up there. Everyone remember that vaguely from years ago? I'd have been a long time. Okay, so what are we going to do? 8, 16, 3 times 8 is 24. 60. 7 times 8 is 50. Yes, my brain is fried right now. 56, 40, 5 times 8. So there we go, 0.375. Okay, now we're out of time. So have a good 2 days. Work on rounding more. If you want to get started on fractions homework, you can. So Friday, I'll see you.
I don't know if you've seen what time I sent that email.
Oh, wait, I forgot attendance. One moment. Okay, Abdullah, here. Abiello, Alexi,
Oh, no, I got it.
Amanda, she was here. Okay, Avery, no Avery, Aya, Cade, 2 Daniels. Daniel Munn is here. Other Daniel, no. Okay. David, here. Diana, here. Elena, here. Israel, Jaron, no Jaron. Carl, Kishwan, Kahil, Kishwan, Sean.
What was the name that you said? Khalil.
Kalel. Okay.
You can say it.
I can say Kalel. Okay. Kit. No Kit.
Dude.
Matthew.
No.
Michelle. Nikki. Kit was here. Okay. Thank you, Kit. Mickey. Get there. Okay. Verna.
You're gonna have to get here earlier.
Verna. Riley here.
Oh, we have
Ryan
13 minutes.
here. Samantha. Samantha, here, okay. Sarah, Shane, Sheila, Sid, Sid. What's your name? Sean, not yet, but I can. Sonia. Unique, and Vincent. Vincent, okay. So no Sid, Shane, Matthew, or Avery. Okay, yes.
So, do I need those 2 papers that you handed out today?
You don't need them, but it's really annoying to have you're trying to do homework on your scratch paper while the problems are on a screen.
Yeah,
So I give everyone to turn in problems on paper.
okay.
So if you don't need it, then you don't need it.
I mean, I don't know, but my other question is that recommended, this book?
The book, yes, you won't have enough homework practice without the book.
Again, so
You could do 12 or 13. This one is much cheaper.
Okay.
Yeah.
Yeah, thank you.
You're welcome.
I already have it. You already have it, that's so exciting.
Yes.
Hey.
Daniel, oh, other Daniel is here. Okay. Okay, yes. So, but you weren't the one I worked with. Okay, so we need to go do ad slip thing. Okay, so hang on.
And I'm on the wait list for this class, so is there any way I can get into the class?
Sure, we have seats.
Okay.
So same thing. Hang on, I have to get her things from the printer, and then we'll go to the math office.
Okay.
Okay, yes.
I'm wondering if I could not turn in, but can I visually see on my checklist that I kind of turned it in? Because I want it physically just to refer to, unless you need it.
Is this notes?
I know that's the yellow.
Oh,
We get points for that, like
No.
the star, right?
only the turn in one.
So the notes for the green one.
The green one is what you get rated. I mean, the yellow one is just enough practice that you can do the green one.
But isn't there like a star where you get a check if you turn in certain?
Just wanted to turn in notes for the show.
Yeah, you will,
Yeah, because I want that star to be checked.
okay, we can certainly do this. That's right. So there's the 10 textbook homework problems with nice steps.
And that would be the yellow page, right?
So yes, if you have all of
Yeah.
them done for the yellow, and there's 10 of them, then so 1, 2, 3, 4. Okay, more than 10. Okay, and your name was
Nikki.
Nikki. Okay, so 10, nice.
And I
Okay,
plan on
that's done.
going to the math resource and outreach, getting those things in.
Okay,
How do we get you the code? I sent you an email with my code
Code.
for the,
and okay, I didn't see it if it's not here.
no, it's not here. I just sent it.
Oh, just sent that, okay, then I
I
will
did
add it
do-
on.
okay.
So,
Two things.
yes.
You check to see if you put me down for yesterday, since you had 2 Daniels in your class.
I didn't yesterday, this Daniel's new, so you were here yesterday. Or Monday.
Also, the second time I sent my code, I had one missing. So, or I had it wrong. And 7 ended up not